Okay, so one of the things that I'm going to try to show you is that using an IDE is basically one way to develop programs, where you basically have two components built in together. So the left side is basically your editor, where you type a program, and the right side is where you execute the program. But as you move to other environments, you can use an IDE. IDE means an integrated development environment like this one. Or you can use your own environment where you basically have these two components separated. And as soon as you leave CS1, one of the things you have to get comfortable with is using the other environment as well. But if you're, for example, using an IDE for C++, you probably have to get something other than Wing, because Wing is customized for Python. So generally, you basically have to have these two components, but separately. One of the things that you have to have is an editor for typing programs. And I use Emacs because, honestly, that's the best editor in the world. But most people will say other things. So this is an editor like any other, where you can start a program. Okay, so this is the same thing that I can do, whatever I can do in my regular editor side of my IDE. And then I will need a way to execute this program. So I actually saved it on my desktop, so it's easy to see. And I'm going to just print hello. Okay, we'll start with this. So what I do need is a terminal that allows me to actually execute this program. And this editor has to be in the same folder as my program to be able to execute it. So I change directory to where this is stored. And then to execute a Python program, all I have to do is just say Python, the program name. This is really what happens when you actually click play here, which will actually call Python and the program name. So it's the same thing, except now I'm doing this here. So in the terminal, you can do many other things. Like, for example, if you have a C++ program, you can compile and run it. But that's, not really what we are learning today. But just so that you can see, I'm going to start using this dual environment from now on. So what we want to talk about today is TkInter. And TkInter is actually very different than the things you have seen so far, because it basically has what we call event-driven programming. All the programs we wrote were basically a single line where you start from the beginning, you execute some commands, and then eventually it ends. And in between, you may be reading input from the user, you may be printing, but when you're reading user input, you read the input until the user submits something, the program is waiting, right? It doesn't do anything until you say print, until you you enter some input, you press enter, and then the program continues with the next step. Are we okay so far? So in essence, the whole program is driven as a single line. But that's not true for event-driven programming. In event-driven programming, you have this one single program that is running all the time. It's almost in an infinite loop. But it is not an exact infinite loop, because while it is running continuously, it waits. It listens for events to happen. And those events can be many, many different things. So the only one that we will really see in this class is clicking a button. Okay? And in purest terms, that's not an event, because it's actually two events. Because you click a button, and then you release a button. So in event-driven programming, you can actually listen to many different events, as much as clicking a button, releasing a button, clicking the left button versus the right button, moving the cursor, typing something in the keyboard. These are all events that you can listen and capture. And for each event, you can write some sort of action that will change your interface. So that means you have this one main loop, and all of these things are happening while your main loop is going. So it's not like a for loop, because a infinite loop is one, but it's just stuck, doing nothing but that loop. Whereas in event-driven programming, your main loop is one where you're not stuck, you're actually listening for events to happen. Okay? So I spent some time this weekend to write this for those of you who are new to event-driven programming. A lot of the tutorials that I find for TkInter assumes you understand all of this. Okay? So we will kind of start slowly but get very fancy very quickly, and interrupt and ask me questions. I am not guaranteed to be able to answer all of them because I am not an expert in TkInter, but we will start with that. So let's start with this very simple program. So generally the way you use TkInter is basically importing everything from it into your main program just to make life simpler. You don't have to, but we are going to just start with the simple program. All right, so from TkInter import star, and then I am going to create an object of type tk. Okay, so if I didn't use it like this, but if I use import TkInter, I would have to say TkInter.tk. It's just that both are fine. It is just that this is simpler, so this is why we are going to do. And then I am going to do root.mainloop. Okay? Remember that root is a object of type tk. The tk objects are extremely complex. That's why it's kind of tough to learn this, because there's lots of things going on. And I will try to explain what I mean by all of that. So let's run this very first program and see what happens. Remember that I basically edited this program and saved it. So now I can run it. And this is what my program does. It creates an empty window, okay? And then it's just waiting for commands, things to happen. Because of this line here, root.mainloop. And in fact, when my Python program is running, I see this little rocket, which is basically the graphical part of Python that pops up this widget here. Okay? So the point is that it's a simple program that does nothing, but also does very complex things. For example, this window that it has, it's already sizable, so you can resize it. It has this property that it can be resized. And it has these three different actions you can have, which any window in your computer can do. So it's inheriting the same functions the user interface in your computer has. So each of you have a TkInter for your specific operating system, because it's basically using whatever the operating system has. And if I were to close this, then it is going to exit from the main loop. Okay? Just to see that this is true, I am running my program, but it actually did not print hello, right? So it's actually stuck in this main loop until I exit this program. So I'm going to close like this, and then it will print hello, and then I'm done, okay? Just so that you understand, the main loop is a stucking point, right? It's stuck there. It's not going to execute anything under here until the main loop ends. Okay? Any questions so far? All right, so obviously this is a useless program of an empty window. So generally you don't want an empty window, you want to put stuff in it. Okay? So the two things that we are going to learn is containers and widgets. Okay? You have to kind of get familiar with these two terms. They are important. So if you are designing any user interface, widget is basically a useless term that's been invented for user interfaces. A widget is an object that does something, okay? So an object that is visible to the user and can be modified and have properties. So Basically, here's my question. How many of you ever use in your daily life a terminal-based program? Like the ones we've been writing. Like you only have input-output. We don't, right? We only use graphical user interfaces. We use interfaces that are embedded in web browsers, or we sometimes use interfaces that are built for our mobile phones or a game, that you play on your computer. All of these are user interfaces, right? So that means everything that is visible to you in these user interfaces is a widget, right? But obviously, it is not so easy to really group these widgets without really having some way of grouping them. So that's when the containers come in. Containers are invisible items that allow you to create groups of things, and you can control the placing of these groups by putting the frames in different places. So the only frame that I know is, the only container that I know is a frame, but I'm sure that others exist. And the only two widgets that we are going to use in this class are buttons and canvas. But there are many others. There are things like you have menu items, you have radio boxes, you have check boxes, you have text boxes where you can enter text. All of these are different types of widgets you can use. So if you understand what I do in class today, you should be able to read any other class and throw those into your interfaces. It'll become pretty easy. Okay? So the first thing we want to do is we want to take our window, which is the main window, and put inside it a frame. A frame is basically an invisible piece that you can put other things in. Okay? So I'm going to copy and paste here. Okay. So I am going to create a frame inside my main window by doing this. So this is an important part. Okay. That when you create a frame, you have to describe the parent. So all interface elements always have a parent because everything has to run inside this first window that we have. So anytime you create a new object, you have to describe what object it runs inside of. So, so we have the biggest thing is the main window. Inside the main window, I'm going to put a frame. Since I called my main window root, I'm going to call the main frame to be a frame inside root. And then I am going to take this main frame and push it inside. So currently I created an object, but I did not actually put it in the interface. So I am going to put it in the interface by this command pack. Any new interface element you create, you have to pack inside because otherwise it will not become usable. So now let's run this program. Okay? So this doesn't work very well because I should create all my user interface elements first and then start running the main loop, which is the actual thing that runs the interface. Okay? So what happened here? In fact, this is an interface that is completely invisible. So when I created the window it had some default size. Okay? But these TK elements are actually very sophisticated because they don't actually have a size until you put something in it. What I put in it was this container frame, but the frame contained nothing, so it shrunk because it had no size. Since it shrunk, the main window that contains it also shrunk, so it has no size. So now what I do have is actually an invisible interface. It's not something you should do, but I wanted you to see. So the thing that's really important here is that user interfaces, the sizes are basically based on what is contained inside the container. And then the thing that contains that container is sized to the size of the containers inside. So it kind of, the hierarchy helps you to size things that are above. It's not a great program, but I can only kind of come out of it with a Control-C here. Okay. So because this is not great, I'm going to put now a button inside this frame. Okay. So I am going to put a button inside the main frame. And I'm going to have some text. So now I have root. Inside there's a frame. Inside the frame is a button. And I need to place the button. Let's see if, okay. So now this is my baby program here. It has this tiny, tiny button here, which you can press. So it's a button. It does nothing else, because I didn't tell it to do anything when I pressed the button, right? But you see now, the main frame is sized to the size of the button, and then the main window is put on top of that. If you wanted to do 2 buttons, you can do that. So let's create a second button. Let's call this button do nothing, which I think will be very easy to do. So now, I actually have 2 buttons, and then it's sized to the size of these 2 buttons. And all of these widgets have and the containers have a default way of working. So the default, for example, when you pack 2 things, it's packed one after another, top and bottom. If you wanted to put them side by side, you actually have to explicitly tell that when you are packing them, you want to pack one to the left and to the right of the same. If you don't, then it has a default way of doing things. That's what you will see. So for example, I can say that pack this to the left and pack this to the right. So now they are side by side, right? So you tell them how you place them, and then it basically does what you want. So let's add a few more items. What I'm going to do is I'm going to put 2 frames, and I'm going to put 2 buttons on the top frame and 2 buttons on the bottom frame. Okay? So I'm going to take this. So I had a main frame. Inside the main frame, I'm going to actually add 2 more frames. So one I'm going to call top frame, which is going to be inside the main frame. And I'm going to say that top frame I should pack side to the top, and bottom frame and then I'm going to create 2 buttons for the top frame. So you can tell this is what I normally use. So button 1, button 2, button 3, and button 4. So I'm going to call this top left. And I'm going to pack this in top frame. Okay. And then these I'm going to put in bottom frame. The point is that when you're working with an editor, when you become familiar with it, you can actually go much faster. So let's see what we have here so that we can see what we are doing. Okay? So now I have more items. So I have a main window inside of the main frame. Inside that main frame, I have 2 smaller frames. And for each frame, I have 2 buttons, right? Are you following me so far? Button is not defined. Button 1, button 3, and button 4. There we go. Okay? So this is what it looks like. Since now I have grouped the two buttons on the top and left and right, they are left and right within inside that frame. And so is for the bottom one. Okay. Any questions so far? Okay. So now let's use one final widget. Instead of putting these buttons down here, I'm actually going to put a canvas. A canvas is something you can draw things in. So instead of putting buttons, so I'm going to get rid of these two buttons. I'm going to create a canvas. Okay, let me look at. I'm making sure that I don't write canvas incorrectly. Canvas, canvas, canvas. Okay, so you have to tell what the frame it's in. So I'm going to put it in actually top frame. Then you have to talk about the height and width. So you create the height and width certain. So let's say 200 by 200. And I am going to pack the canvas. Okay. So basically I have the following, okay? Not that one. Okay. So basically I have this, right? I have a main frame. The bottom frame is where I put my buttons. And the top frame is I'm going to put a canvas there. Okay, so which is this part. So whatever is in here is going to be the top element. So let's see. Okay. So now the top is where I have my canvas. And then the bottom is where I have my the two buttons. Okay. In fact, you can draw something inside a canvas. For example, you can create an oval. Let's make this slightly bigger so we can see better. So if you're creating an oval, you have to give the dimensions. You have to give the top left and bottom right corners of it. So it's something like, let's say, 100, 100 to 300 and 300. Create ovals not defined. Draw. Create oval self. Oh. There we go. Okay. So the canvas, you can put things in it. You can write text. You can write. You can draw objects. You will see that in the next lab. Okay. So if this is all good, now we are going to get fancy. Any questions so far? So to create oval, you give it a rectangle, and then it will fit a oval inside that rectangle. So you give the two corners of the rectangle. So you don't give, which is kind of confusing, you don't give an x, y, and a radius. Instead, you give the box it should be in. So this way you can have a circle if it's a square, or an oval if it's a rectangle. Anything else? So the top left coordinate is always 0, 0 is top left. And the max x and max y is bottom right. The same way as in images. Did I answer your questions? I don't always hear very well because there's a lot of noise in between us. Yes?
He was asking where's the buttons, so the one that says top left.
Oh, no, buttons. Basically, remember that we have these two frames. So you have one frame, which is the main frame. Inside the main frame, I put in two other frames, right? So like this. So this was my main frame. Inside it, I had two frames. One I called top frame, and the other one I called bottom frame. Right? I packed these like this because I put this in the top and this one in the bottom. Right? When I packed this as top and bottom. Then inside here, I packed my canvas. And inside here, I packed two buttons. So these two buttons, I packed this one to the left and this one to the right. So that's because they are placed that way. You answer it? I hope.
Where did the top and bottom, the top right?
It's in the program. So these buttons, right? This is to the left of the bottom frame, and this is to the right of the bottom frame. What else? Questions? Come on. Anything else? Does this interface do anything? Does it do actually anything? Well, other than circle, does it do anything when I press the buttons? No. All right, so now we come to that part. Okay? So do you have issues with the layout? Ask me now. Okay, so now it's kind of tricky for the user interface to read input, because when you read input, when a button is clicked, it has to basically access many different objects. And to be able to do that, you can do it in one of two ways. The one way you can do is have millions of global variables. And you know how much I love global variables, right? The other thing that you can do is to create a class that incorporates all the objects that you want to manipulate in the different programs. So generally speaking, when you write a user interface, you don't actually write it like this. You put all your user interface objects in a class. Okay? So we are going to basically write the same application, but using a class. And I'm going to use a new program so you can see side by side what I do. Okay? I'm going to basically create a new object, a new class. You can call it whatever you want. Okay? Which will assume that somehow the information, the main root window is created. So this is basically all that takes place inside the root. Okay? So basically, the way that I am going to write this is that I am going to actually create my TK window. And then I'm going to create a myapp object that uses this root as parent. And then I'm going to do this. So basically, all that I've been doing is attaching all these interface elements inside the root. I'm going to put all of that inside a class. Okay. And this class can get more and more sophisticated as time goes. So this is kind of the way you create any TkInter application, is that you create your root in your main program, and then you send it to a class which will attach everything that you need that needs to be attached to it. So I'm going to cut and paste this stuff and put it in here. Okay. Now, whenever you don't put self inside a class, those are variables that are local to that function. Any variable that I want to be able to access outside of this function that initializes, constructs the object, it has to be self. So generally, all my user elements, I'm going to basically call them self.variable because I want to be able to actually address them in other places. So I'm going to call this self dot, let's call this the draw button. And this is part of the button frame, which is now we are calling self.button frame. And this one, I am going to call it the quit button. So this is the same exact functionality, except now I have taken all these variables, user elements, the button variables, the frame variables, and I put them all inside this class so I can actually access them in other places. Okay? So that means in my main program, I create the root, and then I send the root here as the parent so that I can attach the main frame to that parent, and from then on, everything is going to go inside that one. And if you want to actually keep track of the parent, you can create a parent variable as well. So this should roughly look the same, except now it is inside a class, right? So you can see it is the same functionality. I just put it inside a class. Let's run this program just to be sure that it does what we want. Now I'm calling this prog2.py. Okay, so it looks the same. I didn't draw the circle. I'm going to put that in a function. Okay. All right, still these are nice buttons, but they do nothing, right? So let's see what would happen, for example, if you basically pack both of them to the left. Doesn't matter, it looks the same. All right, still, all right. All right, so let's do the first thing. What we want is the quit button. When I click it, I want it to actually finish my program. So what I can do is I can add a command for a specific button. That means when you click that button and you release it, you want to call a function. And here, you need to write the function name, not the you don't call the function, you just give the function name. So something like self.terminate. Okay. Remember, it is not like this, because this will call the function. That's not what you want. You want it to tell what the function is that should be called when you click. Now let's define that function. So what we are going to do is, when you execute the terminate function, it is going to access self.parent. Self.parent is actually the root, and the root object, the main object, has a method called destroy, and it will call that method. So find this parent, self.parent, call the method destroy that is part of that object. That object is of type tk, and for tk, the destroy object is going to terminate the whole program. So let's see if we can do that. So when I press quit, it is going to kill and terminate that window and finish the program. Okay? What it does actually, it finishes the main loop. So for example, if you had a print statement here, it will finish the main loop, and then print the statement that comes after that. So basically, the main loop is only executed when exited when you print when you execute destroy. And then let's do something a little bit more interesting. That when you press draw, I want to actually draw an oval. So that means I need to access the canvas so I can draw something in it. So luckily, I stored that in self.canvas. And I'm going to create an oval like this. Okay. So when I do draw, nothing happens because I actually didn't tell it to call that. Okay, so I need to add that here, that if I click draw, I want to call self.draw. So if I keep pressing draw, it will keep drawing this oval, but it's not really going to do anything other than that. Because I've already drew it, so you don't see what happens. So let's get more fancy. So suppose that I want to, when I click draw, I wanted to draw this circle, and then I wanted to clear it the next time I click the same button. So what I'm going to do is, I'm going to keep track of whether I'm drawing or clearing. So I'm going to add a new variable, self is draw. And initially it is true. So basically everything above this point is interface elements. These are other class attributes, right? Whereas these are the interface elements, all right? So one of the things that I want is this variable called self.isDraw. So if self.isDraw, I'm going to create an oval, and then the next time I'm going to make this false, and I'm going to change the button I'm going to change its text from draw to clear. So when you first click the button, it will draw the circle, change this variable to false, and then change the text inside the button to clear. Let's see that. So draw button, because that's not what it's called. It's called draw button. Right? So now this is changed to clear, and you have one. So now let's have the case where I click on this, and the variable is now set to, this variable is this time is going to be set to false. Okay. In this case, I am going to set this back to true, but I'm also going to delete everything inside this canvas. And I'm going to change the text back to draw. Okay, so let's see how that works, just so that you can see side by side. So the first time I click, this Boolean is true. So I'm going to create the oval. This will become clear, and this Boolean is going to be false. The next time I do it, it's going to clear by deleting everything in the canvas. And then this is going to be changed to draw. Okay, simple enough? All right. So now what if I want to draw lots and lots of things? So this is where things are going to get more interesting. Because the point is that when you're adding lots of things to a canvas, it actually takes place very quickly. Unless it's actually many, many things you are drawing, then that may not actually take place as quickly as possible. So let's draw, instead of a single oval, let's draw some number of ovals. So let's say let's say that I want to draw 4 circles. Okay, I did this computation at home, but now it's going to be complicated. So I want to draw 4 circles. So I'm going to start with, I'm going to have them all at the same xy. So the center is going to be, what was it? 200 by 200. And then I'm going to draw 4 circles. So what should be the smallest one? So I want it to be basically starting from that, go up to, from 200 up to 200, right? So if it is 200 radius, so it should be 200 divided by self-num circles. All right, we'll see if this is going to work. So I am going to create an oval that starts at x and y. No, it's going to start at x minus radius, y minus radius. Go up to, remember you're giving a box, right? X plus radius to y plus radius. This is probably not going to work, but I'm working on it. So my radius is 50 at first. So 50 times I plus 1, I is 0. It's going to be 1. So then it's going to be 50, 100, 150, 200. 200 is going to be too large, right? Because it's going to not fit. So I'm going to make my canvas to be slightly bigger so that, all right, let's see what happens. Okay. Of course, 200 by 200 is no longer the center, so let's do that. Okay. 1, 2, 3. Why is it that I don't see the fourth one? Oh, because I go up to minus 1. There we go. Okay, so now I draw 4 circles, I clear, I draw again. Okay, what if I want to increase or decrease the number of circles that I want, right? So basically I want to be able to increase and decrease by clicking on something, the number of circles that I want. So what I can do is I can add 2 more buttons. So I'm going to add, after the draw button, one called increase button. And this is going to increase the number of circles that I will draw. Then I'm going to create one called decrease. Which we'll call a different function called self.decrease. Now, one of the things that's really tricky in user interfaces like this, I cannot say call this function, but also send a parameter to it. This is actually very tricky to do. You can do it. You can call a function by putting a parameter in it, but that requires you use something that you don't want to learn right now. It's called the lambda function. How many of you heard of lambda function? Are you all game majors? right? You will have to learn it if you are really interface developers. It's basically creating a function on the fly inside. But failing that, I'm going to use simple functions because that becomes very complex. Because of that, all my functions are just simple functions that have no input-output. So increase is going to take number of circles and multiply that by 2. And decrease, simply take the number of circles and divide that by 2. But I'm going to make sure that if it is less than 4, I'm going to just set it to be still 4. Or you can do like a min function, okay? So you can say the same thing, saying num circles equals max of self num circles in 4. That will do the same thing. I just don't want it to be ever less than 4, okay? So let's see what that looks like, okay? So now I drew one, but I'm going to click increase. So when I do click increase, now instead of 4, it's going to draw 8, right? So I'm not going to, so this draw and clear, I'm going to add a clear button just so that this is easier. So I'm going to have a clear button. That clears this. Okay. You have all of this in the course notes, so you don't really have to worry too much about writing this down. And then I'm going to simply do this. Okay. And I'm going to just make this a draw function. Okay. So simply draw, don't change it. And if you want to clear it, just use the clear button. Okay. Right, so if you draw, increase, you draw, it's going to draw on top of it. If you want to clear, you can clear. And after this, if you increase this one more time, I believe that it is maybe dry yet. It is unclear. But you may be running into floating point operations because I divided and it's now the radius is 0, right? Because I actually did not use, I used integer division, right? Radius divided by number of circles gave me 0, so now it's a 0 thing, and as you multiply it, it doesn't increase. So there is a point beyond which it doesn't work. You can put an upper limit on that one too, but you can see that that doesn't work. So, okay, so here's my question. It draws all of these circles, right? But it draws them all at once. So generally, when you are seeing something like this, you don't see it working because it is much faster than your eye can see, right? Your computers are very fast. So it's drawing it, but it's drawing it so fast that you don't see it actually happening. So what you can do is you can actually add a delay. The same kind of delay that we see by sleep. If you remember, I talked about that a little bit. So you can actually add a delay so that after it draws one circle, it has a little bit of delay, and it continues and does the same thing. So the way that you can do a delay is I believe called after. So you can add a small delay, like a 10 millisecond delay, after each circle, right? So let's see what that looks like. Okay. That still is not enough. Let's increase that to 100. See if we see a problem. That did not work either. Now the point is that even though it is delaying, there's a thing called queuing. Like all the things that it is delaying are still queued, and then it's shown all at once. So what you can do is you can force it to actually draw whatever you draw. So when you create an oval, it doesn't exactly just pop it in. It will wait until it is finished. But you can force it to actually draw what you put by update, then tell it to wait. Okay, so generally, let's see if this is going to work. Okay, now it did work, right? So let's increase that again. Let's increase that again. Okay, so now it looks like it's animated, but it's actually a trick, right? It's actually always animated. You're just slowing it down so your eye can see. But to be able to do that, you have to do two things. You have to understand how all of this works, because all the circles that you're going to draw, as soon as you say create it doesn't actually just create it. It actually waits, and then it creates it, all of them, and shows it all to you. If you want it to show it to you, you have to use update, right? Which is what this one is. Then if you want it to wait, you can do after. Now, right, so now I'm going to do some interesting things. So now the thing is that you see that drawing it, clearing, drawing it, increasing, decreasing, clearing, drawing it, they are actually all happening at the same time, which is the thing that makes it more interesting. Okay? Again, unlike your program, which basically has a single path, this program has multiple paths. Okay? So in fact, when you draw something, it knows that there's a canvas that I'm going to draw there, right? As it is drawing, and it's drawing and waiting, right? Drawing and waiting, drawing and waiting. Somebody else says, I'm going to clear that, so it's going to clear it. But then this guy who was trying to draw is still continuing, so it's cleared, but it still had to do this much, right? So that still is continuing. And at the same time, I place draw again. That one is started and it's drawing slowly also. So this is the difference between your main program and event-driven programming, because in fact, every single time I click a button, the thing that is executing that button's operation starts the process, and it will go until it ends, right? So when I click the next button, the drawing may still be continuing, but then you may execute a new thing that adds something new. In fact, all of these are threads of the same program that are executing at the same time in parallel. Like the Rick and Morty thing. Oh my God, I know you hate me by now. But it's like, all the Ricks were moving in parallel, right? All of these different functions are executing in parallel because that's what the TK system will support, okay? So these are the three main things that you have to get very comfortable with. One is that your program is not going to do anything until you press a button and you associate some function with that button. Two, you have to place your buttons and so on using these layout managers. So you have frames and widgets, so you have to tell where they go. And three, that remember that this processing actually happens in parallel at the same time. So just to show you this is the lab checkpoint that you're going to start with. If you've already downloaded this, you may have seen it, but so let's get rid of that. So for example, you can go slower, you can go faster. This is all happening because as this ball is moving, I am actually changing other variables that it accesses, right? So since this ball is looking at how fast to move, while it is moving, I can change it at the same time. So this is what makes programming more interesting and more challenging, to remember that one function, when you call it, may be executing. If you press another button, that function may be executing at the same time. If you really wanted to actually control between these two, that one should not be executing while the other is executing, you can basically write some booleans. You can say that I'm not going to wait until this boolean is set to false, right? So for example, let's say that I don't want to kill my window until the draw circle is finished. So what I can do is I can add a, so I have this thing, but I don't use that anymore. I'm going to use a boolean called self-drawing finished, right? So what I can do is I'm going to set this to be false when I start and true when I end. And I only want to terminate my program if this is true. Just to show you what happens if you didn't do that. Okay, let's do this. So I'm going to increase this and draw. And I quit, and it gives me this super long error message. Okay? Because what happened is that I destroyed the program, but the other function was still trying to draw circles into it, but there is no window anymore, right? So it kind of freaks out. So what I can say is that if self-drawing is finished, only then destroy. Otherwise, nothing will happen. Okay? So in this case, okay, so if I were to quit, nothing will happen until it's finished, but now it's going to finish cleanly because it's not going to wait for that. So you have to be very careful when you are going between different functions, just to remember that they are all operating supposedly at the same time, so you have to be aware of that. So, any questions about all this? Okay, just remember that user interface development is much more difficult than you imagine. Okay, so because of that, this TkInter comes with some default settings. You can override them, you can change the color, you can change the sizes, but don't do that until you know what you're doing. I have shown you in, hey, give me a couple more minutes. I have shown you here how you can actually change the size in other examples. For example, you can change the size of a button by the configure. You can change the sizes of, when you put a button, you can add a padding around them. You can do a lot of things. But my most important lesson today is that if you are interested in developing good design, good interfaces, take a class on visual communication or graphical user interfaces from the communications department. They are very, very, very useful skills, very much sought after, but not really taught in any CS class. And if you don't have such skills, use the default settings. Don't really mess with them, right? Don't make things pink and blue and whatever. You saw my interface. That didn't look good, but what can you do? Okay, so good luck, and then I'll see you on Thursday.